Hello Legacy students, Marsh here. So today we're going to look at solving exponential and logarithmic equations. So finally a reason that we're going to learn about these exponents and these logs that we've been working on this unit. So you're going to want your notes, a calculator, and then a pen or a pencil as well today. So to solve exponential or logarithmic equations, you're going to need to know your properties of exponents. So you need to know that if you have a negative exponent, you're going to drop down to the bottom. You need to know that you're going to add the exponents, that kind of stuff. You need to know how to change to logarithmic form. So this 2 to the 4th equals 16, you know that to be log base 2 of 16 equals 4. That's going to become very important today when we're solving. Same thing when you have e to the 5th equals 148.4, you knew that that would come to be to log base e, which remember was ln, of 148.4, and that's going to be equal to 5. So that's something to be aware of. Make sure you know how to convert that, because if you don't, this is going to be a very difficult section for you. And then also the change of base formula, so you can actually evaluate logs in our calculator if you do not have a fancy one. So that would be log base b of a. Remember that was log base a, or log of a divided by log of b. That was how we got that into our calculator, so we could easily type it in and get a value for a log. So that's something to be aware of, guys, that you might need to be aware of. So we're going to look at exponentials first. So there's two kinds that you might see. One with exponents on both sides, and then one with an exponent just on one side. And we'll look at both the kind of examples while you're working on it today. Okay? So, exponents on both sides. What you're going to need to do is think about making both sides equal. And in that regard, you're going to basically want to make it so your bases are equal. Okay? So on this one, I notice I have a base of 3 on both sides. So I don't need to really worry about the base. The base is equal to the base, right? So all I need to worry about now is that these exponents here need to be equal to one another. So I would need to have x is equal to 5 for both sides to be equal, right? Because 3 to the 5th is equal to 3 to the 5th. So let's try one that's a little bit more challenging. Something like 9 to the 2x power equals 27 to the x minus 1 power. Right now I notice I do not have like bases. I need to have the same base. So what I'm going to do is rewrite this 9 and this 27 using numbers, or basically powers, because I know that 9 is equal to 3 to the 2nd, right? I can simplify this, make it so it has an exponent. So I can make that 3 to the 2nd to the 2x, because 3 to the 2nd is just 9. And 27, I can make that 3 to the 3rd, right? 3 to the 3rd is 27. Now you're probably saying, what does that help us? It does, because now I have the same base on both sides. And you're probably saying, well, what are we going to do with these exponents here? Well, remember, if we had an exponent outside of parentheses, we multiplied. So it'd become 2x times 2, so I would actually have 3 to the 4x equals 3 to the, if I do my distributive property here, it'd be 3x minus 3, right? So now, guys, I have the same base on both sides. Now I can set my exponents equal to one another and do some solving. So I got 4x equals 3x minus 3. Let's subtract 3x. And I'll get x equals negative 3 right there. And if you would plug it into your equation, you would get the same answer on both sides, if you would like to make sure you did correctly. Now, what about if there's an exponent only on one side? So what you're going to do, guys, is you're going to isolate the base and then change to log world. Because right now, I can't get to this x as an exponent, because that's just not going to work. So if you ever get stuck in exponential form, you need to jump to log form. And if you get stuck in log form, we got to jump to exponential form. It's kind of the same thing both ways. So what we're first going to do, though, is we're going to get 2 to the x all alone on his own side. So kind of like you would isolate x in that regard. So I'm going to add 1 to both sides. I'm going to get 2 to the x equals 6 plus 1, 7. Now, I'm stuck. I cannot get x alone. So what I'm now going to do, guys, is I'm going to go to log form. So it'd be log base 2 of 7 equals x. Because remember, for log form, the question we're asking ourselves is, what base of 2 to the 7, what exponent on the base of 2 would give me 7? Ultimately, that's what we were asking, right? So, 2 to the log base 2 of 7 equals x. I need to do the change of base formula to get me a value for that, so I actually know what x is. So it'd be log of 7 divided by log of 2, which is approximately 2.81, roughly, for my x. Now, if you would want, you could plug this in, but you would not get 6 on the nose. Just because we rounded, you'll probably get 5.99 or 5.97, something really close to 6. So be careful, guys. If you do plug it in, don't freak out if you don't get exactly the number. It's just because of rounding that's causing you to not get the perfect number right on the nose. Okay? Let's try one with e. So I need to get e to the x alone. Everybody else just needs to move. We gotta get rid of it. So very first thing, let's subtract 1. So I'll have 3 e to the x equals 84. Looks like we need to divide both sides by 3. So I'll get e to the x equals 84 divided by 3, 28. Now, can't get to the x. It is in the exponent. So let's go to log world. Let's jump to logs. So I'm going to have log base e of 28 has to equal x. Now remember, guys, log base e, that is the same as my natural log, Miss ln. So it'd be 28 equals x. So ln of 28, that is a quick calculator thing. You just type it in right there, and you should get x equals 3.33 approximately. Just like I said on the last example, guys, if you would plug 3.33 in for x, you would not get a perfect 85. It's just the way it works out. Now, let's jump to logarithmic equations. Just like exponential, you're going to have two options, two kinds. You're going to have logs on both sides, or you're going to have log on one side. Logs on both sides are super simple. Log on one side is similar to the exponential on one side. Okay, so let's look at logs on both sides first. So we got to think about making these things equal. It's because it's the property of equality, right? So notice, guys, I have log base 5 and log base 5 on both sides. Since they are the same log, would you agree with me that all I need is the stuff in parentheses to be equal? Because let's say the left-hand side parentheses equal to, let's say 2, the right-hand side has to be 2, right? Because they have to be equal. So all I need to do when I have two logs equal to one another is set the insides equal. Just like this. 4x minus 7 equals x plus 5. Not bad at all, right? Let's subtract x. So I get 3x minus 7 equals 5. I'm going to add 7 to both sides. So 3x equals 12. Divide by 3. So x equals 4. And you would get the same thing on both sides. And it looks like it's going to be 9. If I did some quick math, plug that 4 in. So I'd get log base 5 of 9 equals log base 5 of 9, which checks out, no issues there. Now, what about logs on one side? Similar to exponential. All I need to do is isolate the log and then change into exponential form. So right now, I can't get to this x. It is inside the log, so I cannot get at it. So let's convert to exponential form. So it'd be 10 to the negative 2 power equals x. 10 to the negative 2, that is technically 1 over 10 to the second, which is 1 over 100. Right? So ultimately, if you want a decimal, it would be 0.01. But 1 over 100 is the fractional form that you're looking at. Let's try one with a little bit more meat, right? So what about negative 3 plus 2 ln of x equals 5. So guys, I need to get, so ln of x is all alone. He needs to be alone. So let's add 3 to both sides first. So I'll get 2 ln of x equals 8. Need to divide by 2 now. So I got ln of x equals 4. Can't get to the x. It's inside of the natural log. So let's jump to exponential form. What's my base again? Natural logs have a base of e. So it should be e to the 4th equals x. Well, e to the 4th, that is a quick thing on the calculator. So go ahead and find that for me. What is e to the 4th? Go ahead and quickly type that into your calculator. You should get, I hope, about 54.6, roughly, right? Something similar. Now, guys, do be aware, if I type 54.6 into my top equation, you're not going to get exactly 5, just because of round error again. So be careful with that. Don't freak out if you don't get exactly 5. It should be like 4.99 or 4.97 or 6 or 5.01 or something, you know, something close to 5, okay? Just be aware of it. That's going to happen just because we're rounding. Let's try this one. I can't divide by 3 right away. It's inside that log. So it looks like I can't even do anything. I just got to convert to exponential. So it'd be 3 to the 2nd equals 3x, right? Well, this is 9 equals 3x. Divide by 3. 3 equals x. Not bad at all, right? Now, let's look at the last kind. These are the hard versions of logs. Notice, guys, I have log base 4 of x plus log base 4 of x plus 12 equals 3. Notice, I got 2 logs. I have 2 logs. I can't isolate a log if I have 2 logs. So, we're going to use our properties. That's why we learn these properties, to help us expand and condense. So right now, I have something expanded. I'm going to condense this. And I notice that they are added together. So, adding, guys, remember properties, they related to multiplication. So I can make this log base 4 of x times x plus 12. Right? Equals 3. So ultimately, this is x squared plus 12x inside, right? Now, I can't get to these x's, so let's convert. 4 to the 3rd equals x squared plus 12x. 4 to the 3rd is 64, roughly? Can't solve this. Let's subtract 64. Let's get everything to the same side. Maybe it'll look a little neater. Looks like I'm going to have to factor. Okay, so my A times our C, negative 64, and I need a positive 12 when I add. 16 and 4. I think that works. I think the 4 has to be negative, because that'll give me 12. And 16 times negative 4 is negative 64. So I can rewrite x plus 16, x minus 4. So x can either equal negative 16 or it can equal 4. Now, guys, be careful. You do need to check to make sure when you use the properties of logs, you do need to check to make sure you checked for solutions. So if I plug negative 16 in, guys, into here and to here, do you see how I will get a negative under my log? Try to evaluate that in your calculator quick. So log of negative 16 divided by log of 4. And you're probably going to get some form of an error, right? Can't have negatives inside logs. So that's something to be aware of. You cannot have negatives inside logs. That is something to be aware of, something you can immediately check when you have to check for solutions. So since this is a negative 16, it is an extraneous solution. Now 4 does in fact work. You do not need to worry, you can plug it in. So it'd be log base 4 of 4 plus log base 4 of 16 equals 3. Ultimately, guys, it will work out. You could do that in your calculator if you wish, but it's going to take a while, especially if you use the change of base formula. So if you do not get a negative inside the log, do not worry, you are good. It's kind of like how we only checked the denominator on the last one, on the rational functions. You do not need to go through the entire rigmarole to make sure it does in fact work. You just need to make sure it didn't get you a negative. And that's the end of this video. See you later, Sabers.